The last class we sort of looked at the evolution of this field, and the kind of problems that led to, the state of the field today, right? The reason why this whole field started and where it is today. I'm assuming there are no questions, but if there are questions, now is the time to ask. So I'll just wait for a minute. If any of you have any comments, points, questions on the material covered in the last class, please feel free to ask now. Okay, I assume then that there is no question. So what I want to do today is to start on the formal aspects of this lecture class. Remember, we had talked about these 3 R's that constitute the field of CAD, and I had also mentioned that our focus in this class will be the first 2 R's. And I start with the first R today, which is representation. So this is central to your use of a computer tool for modeling a shape, right? Unless there is an internal representation that gets filled up and generated, right? The computer cannot do much with whatever you create, right? It must have a representation for you to query or for you to get printed on paper or on the screen or download it to other processes. And so that is what we will be starting our lectures with, which is representation. And as you see here, representation essentially is a mathematical, right? But may not be an exact model of the object, though our intent will be to always get an exact model. Mathematical also subsumes computational, which means that, it's a model that a computer program can interpret and, do the other things that you want it to do, answer questions such as weight, volume, interference with other objects, etc., or to display. But by and large, we are looking for a mathematical expression. Okay, so that's what we're going to start with today. And so the first thing we need to do is to look at what kind of representation do we want, right? And the reason why this choice is important is that there is a peculiar problem that you all have to be aware of, right? So let's say that you have n different types of entities that you want to support in your CAD system. What do I mean by this? If you stay with curves, let's say you want to support the designer to be able to model circles, ellipses, right? Maybe some other types of shapes, right? Now, if each of them has their own representation, then you're looking at n representations. Now, if you want to use these representations to do something useful, one of the things that you will have to do is say be able to query it for some things. Let's say you want to query it for the length of the curve entity, right? So you want to find the length of the arc of a circle or length of the arc of an ellipse or an arc of an hyperbola, or whatever it is the entity that you want to support. Let me also add the most simple one, which is a line here. Now, what this means, if you have n different representations, meaning a different representation for a line, a different representation for a circle, a different representation for an ellipse, right? What happens then is that let's say that you choose the line to be y equals mx plus c, and circle is some r cos theta. That may not be a good one. Okay, fine. Let's stay with that. Doesn't matter. R sine theta is y, and ellipse is something else. Maybe x square. Is that x square by a square plus y square b square? Is that the representation for an ellipse? Then that's what you have. Now, the moment you have these n types of representations, right, and you want to have a utility which finds the length of each of these entities, you realize that you will have to have n utilities or programs or functions that will do this length of the arc of the curve for you, right? Now, if you want to find intersection between these entities, you must then have so many functions written, right? You have to have a utility for line with a circle and line with an ellipse. Then you have to have a utility for a circle with an ellipse, right? Because of symmetry, I divided by 2, and that's the number of utilities that you must write. Now, that's clearly not a good idea, especially you decide to add one more entity as an afterthought later, right? let's say you decide to add, some kind of a spline curve, right, which has its own representation, right? Maybe some kind of e power minus nx plus e power minus ny kind of a representation. What it means now is that then to add this entity into your CAD system, you have to add one more utility here to find the length of the curve, and you have to add n more utilities here to do intersection of spline with each of the already existing entities. Now, clearly, that's not a very smart way to do things, right? So ideally, you would like one representation to represent each of these entities, even those that you want to add as an afterthought. Okay, so I hope all of you are in agreement now that it's a better idea to have one single representation for each of these entities. Now you may be thinking, what do I mean by representation? And so I will give you two varieties which are already listed here, in the table that is there on your slide, where the explicit form always takes this, shape, where I have a dependent variable on one side and an independent function of an independent variable on the other side. I also assume that all of you are familiar with this other representation, which is referred to as an implicit representation, which is nothing but an equation in terms of the space variables. Now, I want you to know that you can write down, let's say, all of these, but I'm not going to venture to write all of these in these two forms. I will just write down the first two. Okay. The line, I have already written the explicit form, which is y equals mx plus c. And the line is what this is. Okay. This is the implicit form for the line. For a circle, I can still write this for a very special circle, which is origin at center and radius r. Right. And I can write the implicit form for the circle, which is x square plus y square minus r square equals 0. Okay, again, this is a special circle, but you can write similar forms for other kinds of circles as well. Not a problem. So the point I'm making is that these are generic forms of representation, an implicit and an explicit. An explicit and an implicit. And I can write most entities that I have listed out here. You have to take my word. I hope all of you have already written the explicit form for the implicit form for the ellipse. With some effort, we can write down the explicit form as well, right? And spline is a little vague right now. I will not worry about it. I'm just going to stay with these three that I have there. So I have two possibilities. Have an explicit representation or an implicit representation, right? And we have concluded here it's good to have one representation. So if you choose one, stay with one for all the entities, right? So the question arises, how do you make this decision, right? And so I have listed here what we would call as a desired list of entities, that or criterion that will allow you to choose what representation you should be using. We call it the desiderata, the list of things that are desirable in your representation. I mean, usually when I teach on the board, I will ask you guys for what these desired things are. I'm not savvy enough on PPT to sort of release them one by one. So I just dumped the whole thing on one slide. But I would still like you to sort of think about it and see why these are, the generic markers or tests or validation criteria for the choice of representation. The reason is that these are the kind of tasks or expectations or capabilities that your representation should have in CAD. Okay, I mean, these are drawn up primarily for the task where you are creating new shapes and you want to manipulate those shapes. Okay, so let's just go over these and understand or convince ourselves that these are indeed meaningful, desirable criterion for your choice of making the choice of your representation. The idea being that if a representation can do all of these tasks, then it's a good representation, and that's the one we will run with. Okay, point generation. Right. What we mean by point generation is that if you are given a representation of the object, in this case, y equals mx plus c, say, for example, for instance, right? How easy is it for me to generate points on this line so that I can draw it very quickly? You know, when I say I mean a computer program. Okay. So let me ask you this question. You have these two representations in front of you for the line y equals mx plus c, ax plus by plus c is equal to 0. Now, if you were asked to write a program to generate points on the line, which of these two representations would you prefer to use? I'm not asking for a show of hands, but I would like you to turn your mics on and either shout one or the other so that I know what the general thought process is.
So y is equal to mx plus c.
Explicit.
Okay. Explicit. So how many people are voting for explicit? Just say aye, as in the parliament, you know, and we will say it is unanimously y equals mx plus c, as they say in the parliament. Okay. Let me ask the other way then. Is anybody thinking that the implicit form is the one that you should go with for generating points on the entity? Is there anybody voting for that? Your voice is dragging a little bit.
Sir.
Huh?
Sir, actually.
Sorry, go ahead.
Sir, we actually raised our hands.
Yeah, I know. I realize that, but you know, I'm working on a limited screen here. So let me just put the list of participants and see if that helps.
4 people raise the hand for your first question. Ms. Kumari. 4 people for the first question, and for second, I think one person. Yeah, Rohit.
Rohit thinks that it should be implicit, huh?
No, sir. Explicit. No, sir.
Oh, you also think it's explicit?
Yes, yes.
Okay.
Right.
Is there anybody now who wants to, who believes that you know the implicit is the one that you should use, or nobody? Okay. So I'm going to take it that nobody thinks that the implicit is useful, and in some sense, the answer is right? That you would prefer the explicit form and not the implicit form. The reason for that is the following: that if you are thinking of writing a program, right, you are looking at a for loop to generate points on the line, and your for loop can march along x, you know, within some range for x belonging to x1 to x2. You can then evaluate this y equals mx plus c, and then you can just print x, y. That's all, right? And it's a very nice thing because automatically you know from where to where you want to generate the line, and you know it will generate that without any this thing. And computationally, this operation is the best operation that you can expect a computer to do for you, which is plug a variable, calculate an expression. Okay, computers are very good at this. On the other hand, with the implicit form, you have a problem, which is that you have to rewrite this expression representation that you have, which is ax plus by plus c is equal to 0, as something else. And then you have to do this. Okay. Now, computationally, this is not very elegant because you are actually solving the equation here. Now, because it was linear, I could do it by hand. Imagine the non-linear case for the circle, right? Not so straightforward, though most of you would have done this in your high school, but still you have a lot of checks to do now. Here itself, you have to make sure that b is not 0, right? Before you can do this. In your program, you'll have to have a check that if b is not equal to 0, then do this, else do something else, right? So therefore, it's not a very good way to solve, to use this representation for doing point generation. Point classification, let me say what the problem is, right? Point classification problem is actually something that you have to take my word for it now. You will encounter it when I say you, your CAD system will encounter it repeatedly in your modeling efforts, right? And the question essentially is this: given an entity, in this case a curve, and a point in space, you have to answer the question whether this point belongs to this entity or not. Okay, that's the point classification problem. And you can appreciate why it is important if you say that interference check is one of the things that you want to do with your CAD model, right? You want to see what is the distance between two objects in space so that you can figure out if I can put another object in between them or not in your design. Right? Then you need to know whether these points are not interfering with either of the two objects. And that question eventually boils down to this: given a point and a representation of the entity, tell if the entity point is on the entity or not. Now, same question to you now, which is given these two representations, y equals mx plus c and ax plus by plus c is equal to 0, and some point, say q, right, which is let's say x star y star. Which one of these two representations would you prefer to answer this question, whether q is on the line or not? Again, you can do a voice vote, as they say, or you can do a show of hands. Which of these would you prefer?
In this
Yes?
case, implicit can be taken.
Implicit can be taken. Okay. How many other people think implicit is a good idea? Okay, quite a few. Oh, good. Okay. Is there anybody voting for the explicit in this case? Everybody is turning it off. Good. Again, right choice and the right answer, right? And the answer is somewhat similar. What the reason for the answer is somewhat similar to what I had mentioned as justification for the previous choice, which is that in one case, right, all you have to check is if this expression is 0. And like I said, this is something computers are very good at. Plug a value in an expression and find the value of that expression. Right? That's something computers are very good at. Whereas if you want to do it the other way around, which is in the explicit form, then you have to first calculate, I will call a y prime, and then check if y prime is equal to y star. And then conclude after that. Right? So that's an additional step. And therefore, it is not good. Okay. And therefore, you would prefer the point classification, I mean, the implicit form for the point classification problem. And mind you that this answer that we have chosen is good no matter what the entity is. As long as the representation remains like this, your answer is correct, that for all point classification, implicit form is bang on. Right? It doesn't matter what the form of that function is. As long as it is f of xy is equal to 0, your answer is right. Okay. So these two are, like I said, I mean, I hope the first requirement of point generation comes because you have to, print or plot or, render these objects on the screen. And so you need to know what points belong to this entity or not. So that's the first task. Point classification, as I told you, any querying that you do of the object will invariably require this task to be done. And therefore, this is also important. The third item there is what we have called as degenerate slopes. And this is something, again, you will encounter, right? In the sense that all of you will appreciate that. Let me see if I can make some more space on the side here. Okay, that's all I have. Doesn't matter, right? So let's say that all of you know how to, represent a line, right? Either of these two forms you can write. But let's say you want to collect a set of lines to form a square. Right? So you have to have 4 equations, all of the same form, mx plus c or ax plus by plus c is equal to 0. Right? So now my question to you is that if you want to represent a square like this, right, in some reference frame xy, which of these two representations will serve your purpose? Both, none, or which? Voice vote again is fine with me. Or you can even put your hands up. Explicit. How many of you think that you can represent the edges of a square with the explicit form? 1. Any more? Okay, some more. Oh, quite a few more. Okay, let's flip the choice. How many of you think that the implicit form is best suited for the okay, I see 1. Anybody else? Oh, you switched it off. You had turned it on, but
I think it's the explicit form.
it is the explicit form.
Yes.
Okay. So there is no vote for the implicit form. Yes, Prasun?
It can be done with both.
It can be done both. Okay. Fine, but nobody is voting for only implicit. I take that is the conclusion. Unfortunately, in this instance, all of you got it wrong. It turns out that the explicit form is not very good at doing this. Okay, and why is that? Can anybody say why? So your horizontal line, right, which is here, you can represent it as y is equal to C1, and here you can say y is equal to C2. Implicit in this is that the parameters for the line are 0, C2, and here it is 0, C1, meaning M is 0 and C is C1. What about these vertical lines? What is the representation of these vertical lines in the explicit form? You run into trouble because one of the parameters, M, is infinity. Right? I hope all of you agree that, you know,
Yes,
for these two lines, y, the M or the slope is infinity. And that's bad news because computers are very bad at representing this. You cannot represent infinity, right? And therefore, it turns out that you have to actually store these lines as some different form completely, as x equals a1 and x equals a2. This is not the same as y equals mx plus c. So that is why when you have degenerate slopes, meaning when the slope becomes infinity, your explicit form cannot handle those slopes. It fails. Whereas the other form that we have, which is ax plus by plus c is equal to 0, it will turn out that for these two lines, b is equal to 0. That's the only thing that will happen, which is fine because you can store them as just like you have stored 0 as a argument in the representation. Here, the representations will be A0 or rather A1 0 C1 and A2 0 C2. And so it's able to handle it. And so if I go and look at my the choice I have, then it is very clear that I cannot use the explicit form for, and that's what happens. The next one, I will take the bounded entities, just you know, for no reason whatsoever. What I mean by bounded entities is a line segment as opposed to a line. So a line that goes from x1 to x2. Same question. Which of these two entities is good at representing a line segment as opposed to a line? Any thoughts?
Sir, could you repeat that?
So the interest now, right, the criteria now is that I want to be able to represent what I call a bound entity. Okay. And what I mean by a bound entity in this instance of a line is a line segment as opposed to a line. Right? A line goes from minus infinity to plus infinity, right? I mean, it's not a bounded entity. But I'm interested in representing a line segment, meaning something that has a termination. It starts as x1 and ends at x2. Right, like the edge of a square that you were trying to model. Now, if this is the requirement, do you see any value in going with one or the other, or do you think both are good, or do you think both are bad? That's the question. So let me ask by taking the explicit one first, that how many of you think that the explicit form of the line can be used to represent a line segment? Maybe I should give you the answer because perhaps you are not appreciating the point here, the nuance. If you want to represent something like this, your representation of the line is not just m and c, the slope and the intercept, but also x1 and x2. You have to carry this information along. So when you do this for loop, for example, right, you have to know which x1 and x2 you have to march through to figure out that the line starts at x1 and ends at x2. Likewise, in the implicit form also, you have to carry the two extremes with you. Otherwise, there is no way that you know from the representation that the line goes from x1 to x2. There is nothing in these two representations that can bound these entities. So they're only good at representing infinite lines, but not a line segment. Except when you carry this additional baggage of x belongs to x1, x2, or x belongs to x1, x2, and y belongs to y1, y2. Right? And so the expressions or the representations themselves do not help you. You actually have to do some additional carrying, as I called excess baggage of this things. So I hope you'll agree that we can put crosses against both of them when it comes to bound entities. But a quick follow-up question on this, and why are we interested in bound entities? What's wrong with just living with lines which go from nowhere to nowhere or nowhere to everywhere?
So for making 3D models, we need to loft between two lines.
Well, more than that. Your objective here is to design physical artifacts, right? That's what design is about. You're designing something that you can make or somebody else can make. And so by nature or by definition, we are only interested in bound entities. Right? There's nothing infinite about the objects that we make, right? They all have, finite sizes, finite volumes, finite areas, right? And therefore, it is important that the representation we choose meets this requirement that it be able to represent bound entities. Right? There's no entity that you can create which will need this infinite line. There will be every entity, on the other hand, will need a line segment or a curve segment or a patch of a surface or a specific volume of an object. They're all bound entities. And therefore, it is important that the representation we choose also handles that well. So the last one left is what we have called as space entities here. And let me just go back to this example of the square. Unfortunately, I don't have much space here, but let me just wing it by changing the color on the pen. If I can change the color on the pen to something, if I can find my mouse. I'm not able to find my mouse. Hang on a minute. There it is. So let's say that, you have the square now. Let's say you have used the implicit form to form the square, but now you want to form a cube. Okay, and I have drawn the reference frame there still, which is the x and y like this, and now we have added a z also. So my question to you now is that clearly some of these edges the explicit cannot handle. So explicit already gets a cross there because of the degenerate slopes. But take the horizontal lines. Let's not take the vertical lines. Let's take these lines that are, like this here, this line and this line, and this line and this line here. Right? Which of these representations do you think can be used to represent those 4 edges of the cube? Any thoughts? Okay, let's do a voice thing again. You know, those 4 lines that are there on the screen, which of these, which of these 2 representations do you think can be used to represent those 4 lines? One of them, none of them. Let's start with that first. Any thoughts?
Implicit.
Implicit. Okay. So since you have, stuck your neck out, let me just request you to take the lead for the class and tell me the expression. You can, of course, ask others to help you if they are willing to. What do you think will be the representation of that line?
So I think since we are handling the y coordinate and z coordinate, no, not y coordinate, x and z coordinate. So we will just switch the x into x into z, I think.
Yes. So what you are saying is that the expression for this line would look something like a z plus b
y
plus c is equal to 0.
Yes.
Right. So the representation of the line will still be ABC, except that somehow the computer must remember that when it comes to the A1, B1, C1 here, you have to use X, Z and Y. But when it comes to the A1, C1 here, you have to use X and Y. Do you agree with that? Because if you don't carry that information, then you'll be confused, right? Because for this line, the computer would have stored A2, B2, C2. Right? For this line.
Yeah. Yes.
But here it is A2X plus B2Y plus C2 is equal to 0. So here it must remember that A2 goes with X and B2 goes with Y. Here it must remember that A1 goes to Z, first parameter goes with Z and the second one goes with Y. And that's a pain in the neck, right? Clearly it's not going to work, right? Think of, you even just making a cube and possibly doing something with it with this kind of 12 lines, each of them having this additional piece of information that this is XY, this is ZY, and that is YX, YZ, XZ. This is not going to work. Right? That is because my representation is very closely linked to the reference frame itself. It is not, in some sense, independent of the reference frame. And so if you all, I hope, will agree that that's the outcome as far as the ability to represent space entities are concerned. And again, space entities are important because you are living in 3D. The objects that you're going to design and make are not going to be in the plane. They are always going to be something that exists and holds volume and therefore in 3 dimensions. And so that's the scorecard, right? Clearly, the explicit, of course, is no good at all, but the implicit, while it is good in some, in some key requirements for CAD, right, it doesn't do too well. Okay, in fact, some will also add this to that because you render the object so many times in the process of building a model that you cannot afford any inefficiency there also, right? So which means that we have to say that both representations that we have discussed here are pretty much not useful to you in CAD.
Sir?
Yes?
So one small doubt.
Yes, please.
So what if you are modeling something like 2D sketches, the civil sketches like that? So in that case, we can still use implicit, right?
In that case also you have a problem because of this. Civil structures are also not going to represent infinite entities. No, their buildings may be in meters, but they are still finite.
Yes.
Right. So it's not going to go away. And to the extent that they also have to render these things on a flat sheet of paper, printer, plotter, they still have to execute this point generation utility. And so it will hurt there.
Got it, sir.
Right. Okay. So and of course, you'll also have a major issue because even civil is 3D, right? So they may only do plan, but they'll be showing some details in a section somewhere else. And so you will get into problems there also. So this stays, this score stays. You can't do much about it. But then we have to worry about it because we need a representation that will satisfy these requirements so that we can move on and create a CAD system out of that. So the question now to you is that what do we have? Do we have anything left? So let me just put the scorecard in the next slide here, right? So that's essentially what we came up with. So now, since both are not satisfactory, do we have anything left with us? Any other possibility of a representation scheme? Any thoughts?
Polar representation.
What is a polar representation?
Which deals with the theta and...
Yes, so it is actually not so much a representation as a reference frame. Correct. So I have one reference frame which measures points along these two coordinates axes, X and Y. The one that you are proposing measures it in terms of that. Okay. So in some sense, it is not so much the representation that you are changing as the reference frame in which you are defining it changing. Okay, so that's not the representation, but the reference frame for your representation. But the answer lies in the direction that you are thinking, right? Of the polar form. So let me state the answer here, and then we can look at whether it is really an answer or not, right? So the representation that I'm now going to put down here is something that you would have done in your coordinate geometry days, right? Where y would be written as y1 plus u and x is x1 plus u into x1 is x1. Right? You would have seen this representation of the line as well. Correct? This is what is referred to as the parametric form. Okay. Now, first is I just want to confirm that everybody has seen this before. Right? You have seen a related form for the circle, which is x equals r sine theta and y equals, cos theta, and y is equal to r sine theta. This is somewhat similar to this form. The reason why is that both the forms are actually dependent on a single parameter. The parameter is u here, and the parameter is theta here. So let's quickly now see how it fares in against each of this expectation or criterion that we had listed, right? Point generation. Clearly, it is as good as the explicit one because all you need to do now is have a single for loop in u, and you're done. You don't have to do anything else. So that's a tick. I'm just going to skip point classification for a minute and come back to it at the end. Degenerate slopes. Again, there is no problem here. All that is going to happen is that y2 will be equal to y1, and that's it. Nothing else has to change. Right? Everything else will work the way it is meant to work, and you'll automatically get the right expressions for the equations for the line. All right. So degenerate slopes, also a big tick. Right? Space entity. That's one of the biggest attractions of this form, because all I need to do is add one more and that becomes a line in space, not in plane. Right? So you can drop any of these to be 0, and that particular Cartesian coordinate will drop off. You can keep all 3. So if I have a coordinate system and I have a line that is sort of crossing across the planes, then none of the other representations can handle it. This can. Right? So space entities again is not a problem at all. In fact, there's not only 3D space, it can do any n-dimensional space as well. Right? It can create any sort of what's this called? Hello, I'll call you later. Huh? So that's a tick 2. Bounded entities. Now this is a very interesting requirement that we had, particularly from CAD, because we said that we are only interested in bound entities. And so how does this do? It turns out not bad at all, because if we all agree that U, for all practical purposes in our world, will only go from 0 to 1. Okay, this is by a protocol. Right? All of us agree that you will go from 0 to 1, then automatically your line segment that you have represented above goes from x1, y1, z1 to x2, y2, z2. You don't have to carry any additional information with you. It's built into the representation. You're done. Right? So it has an inherent capability to represent a bound entity, provided, of course, we all sign on to this protocol that U will only go from 0 to 1. Okay. Now we come to the last one, which is missing here, which is point classification. So what was the question in point classification? The question was that you are given an entity and a point, and you have to tell whether this point is on the entity or not on the entity. So how does this representation do here? What do you think? Any thoughts?
You would have to substitute it in 3 equations, like each of the coordinates.
Okay, and what do you expect to get from that? You will solve for U in each of them? That's the only unknown, right? What is the problem? You're right? That the only thing is here you are given the right hand side, which is z square, y square, and x. Let's just keep 2, and I'll write it separately here. Y star equals y1 plus u into y2 minus y1, and x star equals x1 plus u into y2 x2 minus x1. Correct. So you will solve this, you will get a value of u star. You will solve this, you will get a value of u star, and hopefully the two are the same, and you're done. I presume that's your proposal, right?
That's one, yeah.
Okay, good. So that is correct, and it is the obvious one, and it will work well, provided you are living in a world of exact computations. Okay, or integer arithmetic, as the computer science people like to call. Right? But otherwise, if you look at it algebraically here, you have 2 equations. How many unknowns? 1 unknown, which is u, right? 1 unknown. So this is what people will refer to as an over-constrained system. And computers are very bad at solving these kind of systems. Precisely because of this problem here. You will get one value of u star, you will get another value of u star. If you do it by hand exactly, you may get them both to be the same. But with a computer, due to round off and other errors, you will find there is some drift between the 2 values. Now, when do you take them to be the same? When do you take them to be different? You cannot answer that. And so this problem, it turns out, is actually a little clumsy for this particular representation. It is not clean. There is a solution. The one you have proposed is also a solution, right? that I solve, maybe I pick only one of them and solve. Why do I have to take both equations? I take only one of these equations and I solve. But that's not a very clean solution. It's not a very elegant solution. But there is a solution which we will look at a little later. But for now, we will put a cross there saying that it is not elegant. But the game is, I hope, already clear to you, right? Because it is able to handle these three quite well, right? We will prefer to go with the parametric representation. And so we will say that our CAD system will be built on the parametric representation of entities. Okay, so here is the filled form for this one. And, you know, as I said, except for point classification, it scores on all of them. And because it scores well in the last two, the space entities and the bound entities, we take the parametric representation. Okay, now let me see, what do I want to do next? Okay, let me just bring this distinction clear in your mind, because it will keep coming up as we go through this class, right? And that has to do with what we will be referring to as the dimensionality. Right? Already you have seen me talk about space entities, right? And in the first class, we said that we will cover the material in this class in increasing order of dimensionality from line curves to surfaces to volumes, 1D, 2D, and 3D. Right? So we understand, or we make this distinction of dimensionality between two types of dimensionality. One is the dimensionality of the space, right? The world we live in, where the points are. The points can be forced to lie on a plane, right, which is a 2D world, or the points can live inside a room, which is a 3D world, or a box, which is a 3D world. So that's one kind of dimensionality that has the dimensionality of the space. So if it's a planar problem, typically I can get away by using 2 coordinates, spatial coordinates. And if it is 3D, I would need 3 coordinates, spatial coordinates, to represent any entity, any point in that space. Right? So planar space means all the points on the screen of the computer. So I can capture it with just 2 coordinates, x and y, or r and theta, as somebody had suggested in the previous discussion. And if it's element entity, my space is 3 dimension, then my point can only be represented by 3 coordinates, x, y, and z. Of course, you can also have r, theta, and phi, spherical, but we will stay with the Cartesian, so x, y, and z. So that's dimensionality of the space. But we also recognize the dimensionality of the entities that we are talking about, right? Of a point, a curve, a surface, and a solid. Right? Now, the distinction is made by the notion of not so much dimensionality of the points, but the degrees of freedom that you have within that entity. Right? A point, once it is prescribed, you cannot move anywhere. You have no degree of freedom. You are either on the point or not on the point. Right? That's it. So it's a 0 degrees of freedom. On a curve, right, you have 1 degree of freedom because you can be here or you can be anywhere on this curve till this point here. So to locate yourself on the curve, you need to prescribe 1 degree of freedom. Right? Same ways in the case of the patch, right? For you to locate yourself anywhere on this patch, you need 2 numbers. I go along this direction and that direction, and I locate myself. So a surface has 2 degrees of freedom, and lastly a volume. So it can be, you know, right, up, in, right? So 3 degrees of freedom. So this distinction you must keep in mind. So I may use 2D, 3D when I'm referring to the space. 2D means I'm referring to a planar space, and 3D means I'm referring to a box or your world. When I say a dimensional entity, right, then I refer to the degrees of freedom of that entity, though I still refer to it as dimension. So point is a 0 dimension or a 0 degree of freedom. Curve has 1, surface is 2, and volume is 3. Right? So you must keep in mind this distinction because sometimes the context, I may not use it correctly, but this is the distinction that I can have. Clearly, the curve, right, can be in the plane, can be out of the plane as well, right? That's where this name of space entities came, because some entities can exist both in a plane and out of plane as well. So a line can be like this, a line can be like that. So that's the reason why we made a special mention of space entities, because irrespective of the dimensionality of that entity, this is about dimensionality of the space it occupies. It's not on a plane, but it's inside a 3D box. Okay, so just keep that distinction in mind, and let's go now on our way to represent or look at the parametric representation. Right? So the parametric representation in the general form, right? We saw the one for the line, but essentially we wrote it as each spatial coordinate is a function of the parametric variable u, right? So if I'm looking at a planar entity, then x is f of u and y is g of u, right? And the other caveat is very important. U is bound between 0 and 1. And the space curve, which is the entity which is not confined to the plane, but can also be outside the plane, essentially has now 3 coordinates, where the last one also looks the same. Z equals some other function of u. Okay, so that's the parametric representation. Now, again, we have to go through a similar kind of decision-making process within a parametric representation as well. The first of them happens to be is that what should the form of this function be, right? Because your equation solving, finding the length of the curve, they all depend on this form of the equation, right? The equation can be a polynomial equation, right? X equals a1 x1 plus a2 x2 and so forth, right? It can be a harmonic equation. It can be a1 cos x plus a2 cos 2x and so forth, plus till whatever limit you have. It can be hyperbolic or elliptic, e power x plus a2 e power 2x and so forth. And there are many such forms of equations, functions that I can choose for my parametric representation. Question is, which of them will you choose? Now, as it happens here, it is already showing up on the screen. So the answer is indeed a polynomial function. And the reason for the choice of the polynomial function, which is the first variety, right, is 3 things, right? One, that it is a unique valued function, meaning that you plug a value of u, you will all. Oh, what did I do? None of you are also catching me. These should have been the variable u actually. I just pulled the fast one on you and you didn't see it. It's a1u plus a2u square. It should be cos u cos 2u, and this should be e power u 2u and so forth. Okay, so please note this. This is the parametric variable u. So a1u, a2u square and so forth. So the first thing is that with the polynomial function, you're always guaranteed a unique value back. No matter what u is, no matter what a1, a2, a3 are all chosen to be, if you plug a value of u, you'll get a unique value of x back. And that is very desirable, right? That you want your function to be single valued. The second is that it is very well behaved. And very well behaved mathematically is sort of expressed in terms of these 2 attributes. One is that there is no break inside the entity, meaning that for the polynomial expression, no matter where you evaluate the polynomial, you'll always get a value that maintains continuity of the entity. There will be no break. Okay, there will be no break. There is just a timer for myself. We have 2 more minutes, right? So it's continuous in the function, But not only is it continuous in the function, but it is derivatives, right? When I look at the rate of change. So for example, if I look at x, it is continuous. If I look at dx by du, it is continuous. If I look at the second derivative, it is continuous, and so forth. At some point, it may be zero, right? For example, in the quadratic case, there is a first derivative and the second derivative is a constant or zero, right? But it is always well defined and clean, unlike some functions where the derivatives can tend to vanish. And that's why we say that it also has no singularities, meaning that the function cannot suddenly jump to infinity or minus infinity, like some of your harmonic or elliptic functions can do. And so that makes this a very desirable function to be representing your parametric entity. And so at the end of this, we conclude that not only is the form like this, but actually speaking, P of U, right, will be a polynomial function. And therefore, if I want to write X as an example for you, I will write this as A0 plus A1U plus A2U square all the way till some AN U to the power N. Okay, so that's the first decision that we have made for this particular case. Okay, and then we need to make some more choices. So I will stop here, and if you have any quick questions, I'll be happy to answer them now, but otherwise we will do a recap on Monday, and you can again ask me questions. So any quick questions, please go ahead.
Sir?
Yes, please.
So now we have CAD lab, right?
Oh, we don't have a CAD lab now, as in I am not organized for you to have a lab right now. The bottleneck for me is to see if I can arrange some online instruction to you before you can start your lab exercises. So after this, when I leave this, you're free. There's no instruction after this.
Okay, sir. Thank you.
Thank you. Okay, I'll stop here and I'll see you on Monday, the same location. Thank you very much.
So
Yeah, yes, please. Yeah.
Lab, the resources that we require, will we be doing that kind of stuff in the first lab session, or will we have to have it ready beforehand? Because I don't
no, we will have to have it ready beforehand, but I will announce that. I will announce that. Depending on the kind of tools on which we can get you instruction, that decision will be made. So we will announce that before. We won't expect you to sort of come there ready and we start. No, you will get advance notice so that you will have access to it, and we will ensure that we pick something that all of you will have access to.
All right.
Yeah. Yes, Yuta.
No, it also, I have no question. Thank you.
Oh, okay. Okay, fine. So thank you then, and then we'll pick it up from here on Monday next. Thanks.
Thank you, sir. Bye.
Bye-bye. Yeah. Bye.
Thanks.